Okay, so I'm actually gonna talk in this video. We're gonna talk about having a projectile that has an initial velocity that is at an angle. All right, so let's look at this. We have V naught and it's at some angle theta. This is like a zero with a line through it. Some angle theta above the horizontal. And you can see this kind of dotted line I drew is parallel with the horizontal, so this theta would be kind of even with that. And it's gonna be launched from a cliff of height h. So let's look at what the trajectory would look like. So if it gets fired out, it's going to kind of go up and then down. This is kind of like when you had just a 1D or 1D motion, like the lid where it went up and then it went down. But anyway, let's look at how to deal with this. This is basically going to be a 2D problem, and it's going to have two parts to it. So first, let's kind of divide this in half. At this highest point right here, that's like kind of like, imagine a movie that you know is going to have a sequel, and it goes up, it shows like a cannonball, fired into the air, it stops, and that's like freeze frame, and you know in that sequel that's going to be where the cannonball starts and it falls back down. So we're going to look at the trip up. So I'm going to call this part, like right here, up, and then this side down. Now this is new. This is something we're going to have to kind of deal with. So I'm going to show you what to do with it and kind of a memory trick for it. So if you notice, this goes both up and over. So that means that you can break it down into its component vectors. This would be a resultant, this is your component. That theta is going to kind of get cut off. So you're going to have an x component here, and you're going to have your y component here. Now if you remember, your x component is going to be v sub x, and then this one, because that's constant, this velocity, your x velocity, remember there's no acceleration in the x direction, is going to be constant. This right here is going to be v initial, and that's just initial because you have your x and your y, and the only way you have your acceleration, since this isn't free fall because it's a projectile, is acceleration due to gravity, and that's acting in your y direction. So you have this. So you can actually find out how long this has been in the air, how far it's going to go. You can find out all kinds of stuff just from this. And there is a way to break down this into these components. So I'm going to erase Vx and V initial here, and we're going to write something else. Okay, this is kind of like the SOHCAHTOA thing from geometry, but don't worry, you're not going to have to do that. So this is a memory trick. See this? This is theta. See, your x, your horizontal velocity, is closest. Yes, I mispronounced that on purpose. Closest to the angle. So that would be V naught. Don't forget the V naught because this is part of it. And that this is not just means zero. It's just another way of stating things. I use it personally for overall velocity when it's at an angle. So V naught cosine, COS. That's the abbreviation for cosine. And then don't forget your theta because the angle plays into it. All right. And then this one, it's on the other sine from the angle. Yeah, I said that wrong too. It's the other sine. So this one would be V naught because it's a piece of this. Sine, which is spelled sin because it's, you know, abbreviation for sine. And then don't forget your theta. So let's look at what you actually have for the trip up. Your x and your y. Okay, and then we know that time is going to be the same for both of them. We do not know time. Oh, by the way, let's look for this. Let's look for max height. Okay, and let me show you for your maximum height. Get a different color. This is going to be your maximum height right here. Now, if you notice, this is h, just this piece of it. Okay, and then you've got this whole other piece right here. And I'm going to call this little piece, we're going to look for it, but I'm going to call it like little h. So we know that your height total, your maximum height, is going to be little h plus big H when we get to it. So we're going to need to find little h here in just a second. But let's finish setting this up. Okay, so you know no acceleration on your x side. Acceleration on your y side is negative g. Okay, we don't know the time. Let's look. You know you're going to have Vx over here. And you know over here you're going to have like this, which we're not looking for right this second, but we will. Anyway, so you got Vx over here, and you're going to have, I'll just call this S. Okay, so you're going to have your initial velocity, your final velocity, and I'm going to call this little h, and we're going to say question mark. Now if you notice, this is going up, so I don't need to put a negative here. Now let's look at what else you have. Well, draw a line back to this. You have your initial velocity. It's just this part. We're going right here. So your initial velocity would be v naught sine theta, because it's on the other sine from the angle. And if we're stopping it right here, we're just looking at this part. The very top, you know that you're up and down because that's where it's accelerating. So your final velocity at the top, just like if you threw something in the air, will be 0. Don't know the height. You do know, remember that this v naught cosine theta is your x velocity, so it's the same all over. So anyway, and that's for your x. Remember, there's only one here because there's no acceleration, so this would be v naught cosine theta. And then you will need to find your max height, we're going to find this. So let's look at the kinematic equations real quick. Okay. That's an equal sign, sorry. Okay, so we know we don't have time, we know we don't have height, we know we're looking for the height or the vertical displacement. So really just basically the one that doesn't have time. So you would use this one. And so that would give you, first, we know that that goes away, and we know that this is going to end up being negative g. So this will give you, I'll subtract vi squared, I squared, so you would have negative vi squared equals negative 2gs, negative 2g, and actually s I should change to, because remember we're calling this h. Therefore h equals, okay, see this v naught squared right here, or v initial squared? I'm going to show you, I know some of you in other math classes know a different way to write this. Write it this way because it'll help you with spreadsheets. So I'm going to go and plug this in for this. V naught sine theta, and I'm going to do it this way. I'm going to put it in parentheses, I'm going to square it, I'm going to put that all over 2g. So this, and I'm not even going to write that in with the h, I'm just going to draw it right here. That gives you your maximum height, which will be useful for finding out how all of your information about the down trip.